Okay guys, before you even look at your note sheet, I just want to do two warm-ups in this video. The first thing I want you to do is pick out which supports the following conjecture. And if you remember, a conjecture is an unproven statement that is based on observations. So right here, which one supports the fact that all perfect squares are odd? So as you see, 16, 25, 64, and 100 are definitely all perfect squares. But out of all these numbers, the only one that's odd is B. So my final answer for this problem would be B. Okay. Let's look at the second example. Which statement is a counterexample that shows the conjecture to be false? And a counterexample is a specific case for which the conjecture is false. So here I'm saying all perfect squares are odd. So which one would not fit in? Take a second, pause the video. So out of these numbers, 9, 25, 49, and 144, they are all perfect squares. But 9, 25, 49 are definitely all odd. The only one that's not odd is 144. So this would be a counterexample. Okay? So that's two examples from section 2.1. All right, now we're going to start notes on 2.2. And notes on 2.2 start with a conditional statement. And a conditional statement is a logical statement with two parts, a hypothesis and a conclusion. And a conditional statement is always written in the if-then form in geometry. You can have a conditional statement not, but in geometry, whenever I am talking about a conditional statement, I will want it in an if-then form. So let's take a look at the example. We have the sentence, if it is raining, then there are clouds in the sky. What you have to know is that the hypothesis comes after the if. It does not include the if. So if I said on a test or quiz, what is the hypothesis? You would just say, it is raining. The conclusion comes after the then, and you would not write then, you would just write, there are clouds in the sky. Later, we're going to talk about truth value to conditional statements. But right now, this is all I'm going to stop at, and you just need to understand that a conditional statement is a logical statement with two parts, a hypothesis and a conclusion. On our second example, I'd like you to take a sentence, for example, all birds have feathers, and I'd like you to put it into a conditional statement, meaning it has to have an if and the then. And please, let's make an English statement. If there's not really a subject, you might have to put it into a subject. So for example, number 1, you can't really say if a bird then has feathers. Makes no sense, people. So what do we say? Maybe we say if an animal is a bird, then it has feathers. So we're taking our hypothesis, birds, and we're putting our conclusion after it, it has feathers. So here would be my hypothesis, an animal is a bird. And then this would be my conclusion, it has feathers. Okay? The next one, it has a subject already. The angles is the subject. So if I had to put if two angles are supplementary, then they are a linear pair. So it's a little easier because it has a very specific subject and conclusion. Again, hypothesis would be after the if, two angles are supplementary, and the conclusion would be they are a linear pair. Or I'm sorry, then they are linear. Oh, I forgot pair. Okay. The second vocab we need for 2.2 is a converse. And a converse of a sentence, of a conditional statement, simply just switches the hypothesis and the conclusion. So for example, in our original sentence, we had if it is raining, then there are clouds in the sky. That's our conditional statement, our original. The converse of this statement simply takes the conclusion, there are clouds in the sky, and if it is raining, and switches them. So instead of my sentence saying, if it is raining, then there are clouds in the sky, it will now say, if there are clouds in the sky, then it is raining. And again, in a second, we're going to talk about truth value and what that means. Is it true both ways or not? So right now, all you have to know is a conditional statement is if then, and the converse switches them. And I know they both begin with C, so they can be a little tricky, but you have to know the difference between a conditional and its converse. Our third vocab word is a negation of a sentence. And really, this does not play a major role in this chapter, but you might see it somewhere that if you're negating something, you are simply just doing the opposite of the original statement. And so, for example, if I gave you the sentence, the suit is black, the negation would be, I'll just write it. The negation would simply be the opposite. The suit is not black. And it's basically using not as a negation. Let's look down here. The sky is not red. The negation would be the sky is red. So that's it for negation. It's not very hard. It's not very easy. It is very easy. Let's see if you remember this. Okay, so hopefully.
Okay, all right, it's blue-gray, but it's certainly not black, right? All right. Let's say it's gray, but it's not.
It is gray.
Okay, so a not joke was, I would say, that suit is black. Not.
This suit is not black.
No, not has to be the end.
Okay.
Okay.
This suit is black, not.
This suit is black. Pause. You know what a pause is?
Yes.
This suit is black. Not.
This suit is black. Pause, not.
No, you don't say pause. This suit is black. That's a pause. Not.
This suit is black.
Okay. I'm not
Not.
quite.
So hopefully you remember that from Borat. It's a little not joke. But negation is simply putting not in the correct answer or taking not out. Let's look at this. If you pause the video for a second, if the following sentence said if J, then K, what would be its converse? If you remember, converse switches the if and the then. So it would be if K, then J. So B would be my correct answer. Take a second, pause the video, and see if you can answer this. If the original conditional is if not J, then K, which one would be the converse? Remember, here's the conditional, here's the hypothesis, here's the conclusion. So if I just switch these, it would be if K, then not J, so B again, okay? And the last thing we need to understand from this chapter, from this section, chapter 2, section 2, is that for a statement to be a valid definition, the statement, the original, the conditional, and its converse must both be true. So for example, if it's raining, then there are clouds in the sky. And don't overthink this, because if it is raining, then there are clouds in the sky. That is an absolutely true statement. Clouds cause rain. So if it is raining, there is definitely clouds in the sky, and that is an absolute true statement. But the conditional, the converse, which was if there are clouds in the sky, so if, and then we took this, there are clouds in the sky, so we have to check, if there are clouds in the sky, then it is raining. Is that a true statement? And you have to think about this. For this to be a valid definition, is that a true statement? So if you think about it, it's false. You can have a cloudy day, but it not raining. So therefore, this one's false. False. This is true. This is false. If one of them is false, then it is not a valid definition. And so here's another example. If I have geometry, no, let's do it this way. If I have Miss Richards, then I have geometry. That's a true statement because the only subject I teach is geometry. But if I say, if I have geometry, then I have Miss Richards, that makes it a false statement. So the definition of me is not just geometry, or the definition of geometry is not me. So something that could be a valid definition would be if an angle is between 0 and 90, then it is acute. So for example, if I switched them, it would be if it is an acute angle, then it is between 0 and 90 degrees. So that would be a valid definition. That is a valid definition of what an acute angle is, and that is a valid definition of what between 0 and 90 is. So you just got to be able to tell those, and that's what you're going to work on next, is the equivalent statements with your partner. All right? Thank you.